Okay, so DeepSeek just shipped a model that activates 13 billion parameters per token, and then casually posts coding scores next to models that are way more expensive to run. That model is DeepSeek-v4-Flash, 284 billion total parameters, 13 billion active, 1 million tokens of context, open weights, MIT license, and the wild part isn't the size, it's how they made long context cheap enough that, just give it more thinking time, actually works. DeepSeek released V4 as a pair. Pro is the 6 trillion parameter flagship, 49 billion active. Flash is the little sibling, 284 billion total, 13 billion active. Both were pre-trained past 32 trillion tokens, Flash on 32T, Pro on 33T. Both support a 1 million token window natively, not bolted on after the fact. API pricing, as of their public docs, Flash is 14 cents per million input tokens on a cache miss, 28 cents per million output. Cache hits drop input to about 0.3 cents. That is not a typo. Under the hood it's still a mixture of experts transformer, DeepSeek's MoE recipe, not a dense 13B. From the public config, 43 layers, hidden size 4096, 256 routed experts plus 1 shared, and 6 experts fire per token. First few layers use hash routing. Experts ship in FP4, most everything else is FP8 mixed. They kept multi-token prediction from V3. They swapped the residual highway for something called manifold-constrained hyperconnections, basically wider residual streams that can't explode because the mix matrix is forced onto doubly stochastic matrices. Math nerd move. Training stays stable, signal still moves. Optimizer, muon on most weights, Adam W on the fussy bits. Faster convergence, fewer loss fireworks. But the real headline is attention. Vanilla attention hates long sequences. Cost goes quadratic. You want a million token context and long chain of thought. Your GPU bill becomes a lifestyle. V4 interleaves 2 tricks. Compressed sparse attention, squeeze every few tokens into 1 kV entry, then only look at the top K compressed blocks. Think, summarize the hallway, then only walk into the rooms that matter. Heavily compressed attention, same idea but more aggressive compression, dense over the compressed keys. Think, blur the hallway harder, still see the whole building. In the Flash config, compression ratios alternate roughly 4 and 128 across layers. There's also a 128 token sliding window so local grammar doesn't get crushed, plus attention syncs so heads can politely ignore stuff. At 1 million tokens, Flash uses about 10% of the single token inference flop of DeepSeek v3, 2, and about 7% of the KV cache. Pro is still only 27% of the flop and 10% of the cache. That's why the window is real, not marketing. Post-training is a 2-act play. First they train domain specialists math, code, agents, instruction with SFT, then RREL via GRPO. Then they on-policy distill those specialists back into one unified model. At inference you get 3 effort knobs, non-think, think high, think max. Turn the dial by more tokens, scores climb. Flashmax numbers from the report their evals, so take with the usual grain of salt, but the deltas are huge. LiveCodeBench 91. 6. Codeforces rating 3052. GPQA Diamond 88. 1. HMMT Feb 2026 94. 8. SWE Bench Verified 79. 0. Compare non-think to max on LiveCodeBench 55. 2 to 91. 6. Same weights, different budget. Flashmax even sits close to ProMax on hard reasoning, HMMT 94. 8 versus 95. 2. Where Flash loses is pure knowledge, SimpleQA Verified is 34, 1 for Flashmax versus 57, 9 for ProMax, fewer parameters, thinner encyclopedia. Fair, DeepSeek v4 Flash is not tiny model punches up. It's a 284B sparse system that only spends 13B per token, with attention redesigned so a million token context and long thinking traces don't melt the cluster. Open weights, 1 million context. Coding and contest math numbers that used to require a much fatter bill. If you're choosing a model in August 2026, use Flash when you want speed, cost, and long reasoning traces. Reach for Pro when you need the bigger knowledge base and the messiest agent jobs. That's the story. Not magic, compression, routing, and a willingness to spend tokens at test time once the architecture made those tokens cheap.